polyatomic ions. We're going to go back to the type 1, type 2 ionic way of naming, but we're going to change our anions a little bit. And we're going to change them to what's called polyatomic. Up until now, we've been using what's called monatomic. All right, where your ion is just one atom, like sulfur 2 minus, oxygen 2 minus, Cl minus. Okay, now you might have had more than one of them. That doesn't matter. It's only the one atom. It's binary. Polyatomics is where you have more than one atom in your ion. So this is what's called a polyatomic ion. There's more than one atom. There's two atoms. There's a sulfur and an oxygen. Don't worry about the numbers. We're not worried about how many there are, just how many different types there are. Okay, so this is one whole unit. This is what's called a sulfate ion. Now in class, I'm going to give you a polyatomic chart that you do not have to memorize. You can use it on exams. They have one in this video in your book. It has a few of them. There are some of them that are not on the sheet. The only ones you have to worry about are the ones on the sheet. Okay, there's pages and pages and pages of polyatomic ions. The one I'm going to give you in class are the most common ones. Okay, so here's a few examples. I don't like these examples. That's like the worst example, so ignore that page. Okay, here's a perfect page of them. All right, the acetate ion. Okay, this is the acetate ion. All right, C2H3O2 with a -1 charge. All right, this is not really a common one. We're not going to see it that often. You might see it in your homework because it's in your book, but that's not going to be on our chart. It looks like all the other ones pretty much you will see. Okay, this is the carbonate ion, the chlorate, the chlorite. Most of them, notice, end in ate and ite. There are a few exceptions. Cyanide and hydroxide, I believe, are the only two exceptions, and peroxide. We're not going to see peroxide that often. Those are the only three exceptions. Everything else is ates and ites. Okay, you notice that? All right, so that's kind of how you know it's going to be polyatomic. But also, notice there's more than one atom. So how does this work? Exactly the same way as we saw. If I were to take a sodium ion and combined it with a carbonate ion, crisscross applesauce, nothing changes, Na2CO3. This is called sodium carbonate. Sodium, I'm probably jumping ahead, but I don't care. You guys can handle it. Carbonate, sorry for squeezing it in there. Okay, because it's a sodium and it's the carbonate ion. Okay, let's say we take let's say we take this ion, chlorite. Draw calcium chlorite. Calcium chlorite. Draw calcium chlorite for me. Put on pause, write it. Okay, welcome back. It is calcium has a 2+ charge. Chlorite has a ClO3 1 charge, so it's going to look like that. Why do I put it in parentheses? I didn't do parentheses here. If you wanted to, you could do parentheses, put that whole thing in parentheses. But why do I put parentheses? Because I have to put the 2 outside. I can't say it's CaClO3 2, because then I'd be saying I have 32 oxygens. I do not have 32 oxygens attached to this chlorine. It's literally impossible. Okay, I don't have a Cl32. I have two ClO3s. Very different. It's like saying the difference between x squared to the third as opposed to x23. These mean two totally different things. All right, it's kind of the same exact analogy. Okay, so put a parentheses if you have more than one of them. If you only have one, then you don't have to put a parentheses. Okay, crisscross applesauce still works the same. Treat this as one full unit. Okay, I'll kind of show you a trick on how to kind of learn the naming of it. So for those of you that go and take Chem 111 or 112, you're gonna have to memorize these. So let me kind of show you an easy way. All right, so look at all the 8s. So here's a chlorate, here's a sulfate. Okay, let's erase these. All right, let me look at the phosphate. All the ones I chose, nitrate. All the ones I chose all end in 8, 8, 8, 8, 8. Okay, now notice there is no pattern. 8s are O3 with a minus, O3 with a minus, O4 with a 3 minus, O4 with a 2 minus. There kind of is a pattern. You can look in your book for it, but it's not exact. It's not perfect. It's not as nice of a pattern as what we saw on the type 1 main group elements, like, you know, everything in the 1As have a +1. There really is no pattern here. Okay, so I just want you to notice the 8. So let's use chlorate. Chlorate, ClO3 minus. All right. All of the ites, the ite version is always one less oxygen. How I remembered it is the ite 8 in oxygen. The ite 8 in oxygen. I have the words ite and 8 in it. All right, so whatever your 8 is, the ite version is going to be one less oxygen than the 8. You still have the same charge. So chlorite, notice, is ClO2 minus. It's one less. Okay. Here's nitrate. Nitrate is NO3 minus. What's nitrite? NO2. Look, it's right underneath it. All right. Phosphite would be PO3, 3 minus, one less. Here's sulfate, SO4, 2 minus. What is sulfite? Well, if you look underneath it, you got the answer. It's 3. Okay. So whatever so really, you only, for those of you taking Chem 111, if you want to memorize these, all you need to memorize are the 8s. You can figure out the ites. So I already decreased this page by, you know, probably a third already, okay? Now you have pers and hypos, all right? Hypo means underneath, below. Per means above, okay? So we have chlorite, and then we have hypochlorite, which means underneath a chlorite. So what would one less of a chlorite be? ClO minus, and that's what we see right here. Hypochlorite is ClO minus. In fact, sodium hypochlorite, NaClO, is bleach. That's the chemical compound for bleach. All right. So notice we don't have any, I don't think we have any other examples of the hypochlorite. The hypoites. But if I had hyposulfite, let's just say, what would hyposulfite be? Let's just pretend it exists. All right. Well, sulfate is SO3. Hypo would be one less than that. So SO2, 2 minus. That'd be hyposulfite. Okay. Now you have pers. Per is above. So per chlorate, we're now one above the chlorate. So instead of Cl3, it's one more oxygen. It's ClO4. Okay. So that's kind of a quick, easy way to kind of read this. All right. But pretty much, if you have a chromate, here's chromate, dichromate, just all different names. Dihydrogen phosphate. This is called bicarbonate. Anything that has one hydrogen attached to it, you always put this bi in front of it. So bisulfate, bicarbonate, bisulfite. All right, it's not on here, but there's a bisulfite, biphosphite. All right. Okay, so these are what's called oxoanions. They're basically polyatomics that have an oxygen in them, like nitrate, nitrite. All right, and all the rules are the same. So why don't we stop? Why don't you, oh, and this is, let me, where is it? These are anions. Oh, these are the cations, sorry. Don't worry about mercury. This is a very short list of polyatomic cations, and this is the most common one that we'll use a lot, the ammonium cation. Notice it's not a metal. This is the only one that you have to be careful of. Okay, remember we talked about ionic bonds are all metals and nonmetals? Well, what if you have an ammonium with a chloride? Notice these are all nonmetals. This is still ionic bonding. It's actually both. I have covalent between this, and then I have ionic between this, because this is composed of the ammonium ion and the chloride ion. So again, something you have to memorize. If you see NH4, you know it's an ammonium. Okay, so let's do this one together. All right, name this compound. So it's composed of the ammonium ion and a fluoride. So it's ammonium fluoride. Okay. Why don't you do the rest? Put it on pause and do the rest. Okay, we are back. The next one, AlOH3. Do the cross-Chris applesauce. Make sure everything is correct. So Al3 plus, OH minus. Aluminum should have a 3 plus charge, so this is correct. And the OH minus, if you look back on your polyatomic chart sheet, the OH minus is called hydroxide. So this is aluminum hydroxide. Next one, iron with an SO4. Let's look, SO4, SO4. SO4 right there is called sulfate. So this would be called, did I pass it? Yes. This is called iron. First I got to figure out the charges. So crisscross applesauce or cross-criss, 3 plus. And then my sulfate here has a 2 minus, which is correct because sulfate does have a 2 minus. So this is called iron, and iron is a transition metal type 2 naming. So iron 3 sulfate. Okay? So I hope this makes sense. Like I said, this is just the lecture part. We do a lot of problems in class or at homework. Okay, we're gonna put this on pause and then we'll come back and do the ask.